Hello and welcome back. Today we will be discussing section 7.2, inverse functions. Before we can talk about inverse functions, we need to review functions. So remember back in Module 3, we needed to determine whether a relation is a function. We're given three examples here. This first one, this relation is a function. And as we can see here, we have inputs of P, Q, and R, and our outputs of M and N. So our inputs are not repeated, they are unique, and so that means that this is a function. We do have a repeated output of N, but that's okay. That still is a function. It doesn't matter if our outputs are repeated for a function. On the next one, our inputs are P, Q, and R, and our outputs are X, Y, and Z. And we can see none of the inputs are repeated, so it is a function. Also, none of our outputs are repeated this time. On this last example, this is not a function because we can see we have two inputs of P and Q, and P is being mapped to X, while Q is being mapped to both Y and Z. So we have a repeated input of Q. So that makes this not a function. Now remember, to be a function, each input has exactly one output. And when we're looking at the graph of a function, it has to pass the vertical line test in order to be a function. All right, so now that we've reviewed functions, let's get into what a one-to-one function is. For a one-to-one function, each x value, or the input, corresponds to only one y value, the output. And each y value, the output, corresponds to only one x value, the input. So basically this is telling us that our x's can't be repeated and our y's can't be repeated in order for it to be a one-to-one function. But make sure that you check that it is a function first and then check if it is one-to-one. Let's look at some examples. So on this first one, we're trying to decide which of these four mappings represent a function. So we want to look here to see, are any of the x values repeated, or those input values? Well, on this first one, none of those are being repeated. So that means that f of x is a function. On g of x, no, those are not repeated either. We can see that there's two outputs that are being repeated, but that's okay. The inputs are not being repeated. So g of x is a function. M of x, also none of the inputs are repeated, so that is a function. And the last one, again, every input is going to exactly one output, so n of x is also. So keep in mind, this is called function notation, and so if it is written in this form, then they must be functions. So all of these are functions. They were written in function form. However, we need to look to see if they're one-to-one functions. They're all functions, but which of them are one-to-one? So now we just need to look and see, are any of the y values repeated? On f of x, each input has exactly one output, and each output has exactly one input. So that one is one-to-one. However, on g of x, like we said before, that 6 is being repeated. So that is not a one-to-one function. On m of x, again, we can see some of our outputs are being repeated, that -3 and that 3. So that means it's not a one-to-one function. And on this last one, there are no repeated inputs, no repeated outputs. So that means n of x is a one-to-one function.